Good afternoon, I'm Katie.
And I'm John.
We would like to thank the organizers of this summit for including our presentation. We are delighted to share some of our work with you. I'm going to give a quick background about the work we are currently doing with community-scale food waste composting. John and I, with another partner, Jen, recently started an initiative called Compost for Good. This initiative builds on the composting work we have been doing for many years and was founded to strengthen our capacity to promote community-scale composting around the world. Several years ago, John designed and built a composter with the intent of creating a simply built, inexpensive, continuous flow drum composter capable of meeting the composting needs of a small community. That original composter has now been in operation for almost 5 years and has seen great success. Since then, 4 other composters of the same design have been built and put into operation at various organizations. The design documents and the operating manual for this community-scale composter are free and available to anyone who has interest. Those documents, along with other resources, can be found at the Adirondack Compost for Good webpage on the 80K Action website. Adirondack Compost for Good is a regional expression of the more global reach of the Compost for Good initiative. Though the initial creation of this composter focused on food waste, the idea was to expand the capacity for composting other feedstocks. John will now describe his experiments with the composting of human urine and the results to date. This urine composting research is a small part of the larger goal of Compost for Good and funded by another organization in the Adirondacks.
We recognize the value of utilizing human urine for fertilizer. Additionally, we recognize that soils in many parts of the world are deficient in organic matter, which is vital for promoting microbial biodiversity, water and nutrient holding capacity, and allowing soils to be more friable. We therefore attempted to see if we could develop a recipe involving just urine and a carbon source to create a finished compost similar to commercial composts that are used by growers. To avoid potential pathogens, we also wanted to know if during the composting process we could achieve temperatures of over 131 degrees Fahrenheit for 3 consecutive days to meet the US EPA standards for Class A biosolids compost. We began this research inside of a moderately insulated building in December of 2019. The facility is at 2,200 feet elevation in the Adirondacks, with temperatures during the time of this work of as low as 25 degrees below zero. Using 30-inch diameter polyethylene road culverts placed vertically on a concrete floor, we placed a variety of different mixes of urine, water, and wood pellets to see if we could get the mixed material to heat up. Inside of the vertical drums, we also placed a manifold made of PVC pipe with holes drilled into it through which we could force air throughout the vertical mix to keep the material in an aerobic state. We quickly realized that we did not have the thermal mass to prevent the thermal energy that was produced from the microbes from being lost faster than the microbes could produce that thermal energy. We then created a space that was approximately 5 feet wide by 6 feet deep by 4 foot high, in which we placed the most promising recipe from our earlier experiments, and which we hoped would contain enough material to have the thermal mass that we needed. During these experiments, we processed approximately 500 gallons of human urine, equivalent to over 4,000 pounds. We have demonstrated that by using a simple recipe of human urine, water, and sawdust in the form of compressed wood pellets, we were able to heat up this mix to over 131 degrees Fahrenheit for more than 3 consecutive days. Results from the Penn State Composting Lab confirm that the finished compost from our static pile is similar to many commercial composts. The urine-water pellet mix was also used with food waste inside of an existing in-vessel community-scale rotating drum composter of our design. We have preliminary results suggesting that this urine-water pellet mix increases the temperature inside of the compost drum and produces a better quality finished compost. In this image, the lighter finished compost is the urine water pellet recipe composted by itself. The darker image is finished compost produced from just unsorted food waste and pellets. We believe that this research could have significant implications for the large-scale composting of human urine. We also believe that on a large scale, upcycling human urine through a composting process could benefit food waste composting, sustainable agriculture, and sustainable forestry. Additionally, composting urine would reduce the load on existing wastewater treatment plants and could reduce the negative environmental impacts from pharmaceuticals that are often found in human urine.
If you have questions about this research or want information about the free composter documents that we've created, then please contact us at this email address. Thanks again for letting us share this research with you.
Thank you.